Okay, today we will discuss about the importance of calculus, in particular differentiation and integration in physics. Okay, in order to discuss about its importance, I just want to begin with finding the slope of a straight line. Okay. Say, I am drawing a straight line like this. Okay. Such a line or such a surface represented by such a line which have one end higher than the other end is called an inclined surface. An inclined surface or a slope If I draw another line like this also, we know that this line will have higher slope than this line, but by how much we cannot say. And another line I draw like this, and this line will have slightly lower slope than this, because this comes closer to this portion and this is product. Okay. So, but by how much we cannot tell it. So to measure it exactly, we just need to give a value to the slope of an inclined surface. So how to find it? I just draw a vertical line downwards like this, and then I draw a horizontal line to meet that vertical line like this. I just know the point of intersection. Okay, these two lines intersect at the angle of 90 degrees. Okay, I measure the length of this end from this intersecting point, and I denote it by heights. Okay, and then I measure the length of this intersecting point from this lower end, and I represent it by B. Then in the next step, I divide value of heights by value of B. Then it gives a result. It gives a value. That value is a value of the slope of this inclined surface. Okay. This is the slope. Value of the slope. Numerical value of the slope of the inclined surface. Here, height is also known as rise. And this B is also known as run. Therefore, height by B is also expressed as rise over run. Okay. Again, if the angle made by this inclined surface with the horizontal be theta, then tangent of angle theta is equal to opposite divided by base. This is equal to slope. Okay. Therefore, slope is equal to tan theta. Opposite is equal to height. Base is B. Okay. To tan theta. But this is for a surface or for a line. Okay. Whose inclination is fixed. Okay. For a smooth straight line, whose inclination is constant. But if I find a surface like this, such a curve, let's see here, the inclination of the slope of the point or region around this point and the region around this point and the region around this point, they all have different values. Okay, And to measure the slope of this points, okay, I just slope of this region in the around this point. I just draw tangent like this, like this, like this, and then find the angle made by this tangent with a horizontal. With the horizontal. Okay. And then after that I find the value of the tangent of the angle theta. Okay. This gives the value of the slope. Okay. If this theta, to make it different, okay, here let this past theta be the value of the past theta be theta 1, the second theta be theta 2, and the third theta be theta 3. Okay. Then theta 1 will be different from tan theta 2 and tan theta 3. Okay. And again, in order to find the slopes of the other regions, I just need to draw other tangents also. But this process becomes a very time consuming and silly process. Then the question comes, how shall we proceed to make it handy? In a time-saving manner. So, in order to proceed, there comes differentiation. Okay. Differentiation. Okay, if we know the process of differentiation without even drawing the graph and the tangents, we will be able to find the value of the slope of the region or slope of the surface at a particular point. Okay, without drawing the tangents. Okay, but how? Okay, in order to proceed, we must know the process of differentiation. Okay, we have already known that if y is a function of x, then the value of y changes with the change in the value of x. And again, for a function to be differentiable, okay, the function should be continuous. Okay, no sharp endpoints. Okay, no gap, no breakpoints like this. Okay, and as the value of y changes with the change in the value of x, okay, if I take a change in x denoted by delta x, there will be a change in the value of y denoted by delta y. Okay. Now divide the value of delta y by delta x. Okay. Till now this is not differentiation. Now to be in the process of differentiation, I just take a limit, put a constraint in the change, in the amount of change of delta x. I just put a limit in the change delta x. I just set the limit delta x tends to 0. That means the change will be very, very small. And to make it visible, okay, to make it clear to our mind, I just write that limit delta x tends to 0. To know that I have set the change in delta x to tending to 0. Okay. Now this becomes differentiation. Okay. So, okay, now I represent this as df by dx. This is differentiation. and it can be represented in other forms like f prime x or f dot x or dxy. And these notations have different names like Lagrangian notation, like Newtonian notation, like D notation, etc. But they have the same meaning. Okay. This is about differentiation. And without even showing how the value of differentiation of a function, okay, comes to that value, I will verify that the value of the differentiation gives the value of the slope of the function. Okay. We know that differentiation of sine x with respect to x is equal to cos x. Okay. This cos x represents the general value of this cos x is the general expression of the slope of the original function sine x. Okay. Let's see if this is true or not by taking 2 or 3 points. Okay. To verify that, I need to draw the graph of sine x and cos x and verify that. Okay. By taking their corresponding value, their respective values at the points. Okay. Let's see. Sine x function curve is like this. Okay. This corresponds to y, this corresponds to x, this 1, okay. This point corresponds to pi by 2, this is pi, this is 3 pi by 2, this is 2 pi. Okay. And now this point corresponds to pi by 2, this point corresponds to pi, this corresponds to 3 pi by 2, this point corresponds to 2 pi. Now, this is the curve of sine x, or the graph of sine x is the graph of cos x. Okay, the graph of cos x will be like this. Okay. Now, let's verify. Here, if I have to find out the value of the slope at the highest point, I just need to draw a tangent here, like this. This tangent makes an angle of 0 degree with the horizontal positive direction of x-axis. Therefore, as tan 0 is equal to 0, therefore the slope of this curve at its highest point is 0. Okay. Let us find out the value of cos x at pi by 2 is equal to 0, pi by 2. Or from this graph, this is the curve of cos x, and this value corresponds to the value of 0. Okay. Therefore, it is verified that differentiation of sine x with respect to x gives cos x and represents the slope of the curve sine x at pi by 2. And now, let's come to this point 3 pi by 2. At 3 pi by 2, the slope is, okay, what's that? Okay. It's something 0, 0, okay. Something 0, 0, okay. I just want to take out the points like, okay, like here. It will come like this, okay. So, at this point, at this rising point, this tangent makes an angle of 45 degree, almost 45 degree, okay, from the, actually the tangent makes 45 degree with the x-axis, but when I draw it seems that it is a little different, okay, but actually the angle is 45 degree, okay. If I have to draw according to scale, okay. So, this angle makes 45 degree. As tan 45 degree is equal to 1, therefore the slope of this region, of this curve at this point will be 1. Okay. But this curve cos x value at this angle, at this region, at this value 2 pi is 1. Okay, this point will correspond to 1. Okay. Therefore, it is also verified that cos x represents the value of the slope, or represents the slope of the function, original function sin x. Okay. Like this, we can also verify at this point also. Okay. At this point also. At this point also. Okay. Here it is negative. Okay. The angle made by this tangent is negative, but at this 45 degree, negative 45 degree. Here negative 1, like this. Okay. So it is verified that cos x is the general expression of the slope of the original function sin x. Okay. After putting the value of the point, okay, or the angle, we can get the instantaneous value of the slope, okay, at that point. Okay. That is, as we have already known that cos x is the general expression of the slope of the original function sin x, if I have to find out the slope of sin x at x is equal to pi by 2, I just need to find out the value of cos x at x is equal to pi by 2. Therefore, cos pi by 2 is equal to, as cos pi by 2 is equal to 0, the slope of sin x at pi by 2 is equal to 0. Like this we have to find. Thus, differentiation becomes a very handy tool for finding out the slope of the function. Differentiation becomes a very handy tool for finding out the slope of the function. Okay, this is about the importance of differentiation. But I just have taken the slope of the idea of slope to visualize the importance of differentiation. Okay, but this is not the only case of differentiation. Okay, it may also represent the value of differentiation. Also represents the rate of change of that function. Okay, differentiation value also yields rate of change of the function. Rate of change of the function. Rate of change of the function. That rate of change of the function. Okay. Okay. General expression of the rate of change of the function. Okay. At any moment, okay, if I have to find out the value of the rate of change of the function, I just need to put the value of the independent variable, in the general expression of the rate of change. Okay, and that gives the instantaneous rate of change. Instantaneous rate of change. Okay. That is how differentiation becomes a very handy tool in physics, in mathematics, in business, in economics, in technology, etc. So, the other idea is about integration. But what is integration? Integration is the inverse of differentiation. Inverse of differentiation. Integration is the inverse of integration, and the process of integration asks the question: what is the original value of the function whose slope is represented by this function fx? Okay. This process represents the question: what is the original value of the function whose slope is represented by fx? Okay. For example, the differentiation of sin x with respect to x yields cos x. Okay. Integration of cos x with respect to x yields sin x. That means this question, integration of cos x dx, asks the question: what is the value of the original function whose general slope is represented by cos x? Okay. This is about the idea of integration. Just that means integration is the inverse of differentiation. And next, we can put the limits to the process of integration. Limits. We can put the limits to the process of integration. We can put the limits to the process of integration. Okay. So, for example, definite integral. We call it definite integral. Definite integral. Definite integral. What is the use of definite integral? The uses of definite integral. Definite integral are useful in finding the areas, volumes of circles, areas of circles, ellipses, surface area of cylinders, cones, spheres, etc. And definite integral is also useful in finding the volumes of spheres, cylinders, cones, etc. So, is this the only use for definite integral? No. There are other fields where definite integral is applicable. For example, in finding the center of mass, okay, in finding the amount of charge accumulating over a time, over a time limit, etc. And not only this, there are other areas where definite integrals is applicable. Okay. Again, differentiation is also applicable in finding the maximum value or minimum value of a function. That process is called optimization. Optimization deals with finding the maximum value or minimum value of a function. Okay. So that is regarding the use of differentiation and integration, and in general the importance of calculus in the field of physics, mathematics, in the field of business, in the field of economics, in technology, etc. That's why I want to discuss about the importance of calculus in studying and in doing research, etc. Okay, up to this is enough for today. Thank you.